Good morning. All right, today is February 3rd. The groundhog saw his shadow, so we will have 6 more weeks of winter. Had he not seen it, we would have had 42 more days. So with that introduction to the class, let's take a look at the schedule. Okay, the schedule for today is more basic graphics. Yay! Tomorrow, not tomorrow. Next one is more basic graphics still. And then on the 7th, we have a review. And then on the 10th, we have exam 1. So a week from today, I guess, exam 1. Be ready. All right. Study hard. Make sure you understand all the material presented in this class. Just a little foretaste of what's going on after that. Recursion, time complexity sorting, blah, 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 time complexity sorting, review, midterm. Oh, yeah, midterm. Yes. So things are happening fast, right? Yes, Scott. I will bring the bubble sheets because they're my own custom bubble sheets. Nobody else has them. All right. So just pay attention to where we are, right? You've got these things coming up. That's why I have the schedule, is so that you can be prepared. I just like to make sure that you're ready. Okay. Anybody have any questions before we begin? All right. I have something I need to do. I have to grab my drink. It's very important. You're going to talk for a while in front of a room, you need a drink. All right. Let's return to basic graphics. IntelliJ is over here. Last time we saw walking the dog. Does, oh shoot. Now I'm going to have to fight with, there we go. All right. So last time we saw walking the dog, and let's just take a look at that again. Do we all remember that? Do we have any questions about that application? Anybody? No, it's all good. Look at him. Isn't he cute? All right. JJ, right? Yes, the clock worker run. The question was, does the clock worker run every so many milliseconds that you picked an initialization? And yes, that is true. Logan. I'm sorry, what? So in my main website at the bottom, there is basicgraphics.zip file, which has all of this code. And that's the thing that you're going to use to build your labs. And the next lab, I guess, is going to be a lab that uses basic graphics to make a simple application. So it'll get you started. All right, let's take a look at another application. Bless you. Basic graphics examples, basic graphics. Okay, so let me adjust my windows around here a little bit. All right, get a little more space. All right. So this class is called Basic Graphics just because I needed a simple name. As before, this is going to start off with create ball. Okay, so this is a thing that you've seen before. On the basic frame class, there is a static method called create image, and it takes an X and a Y size, and it returns to you an image object. It's actually a buffered image object if you want to look at what the Java API has, which is a super class of image. On the graphics, on the image object, there is a method called getGraphics. And if you get the graphics object, you can use that to draw on the image. And in this case, what I'm going to do is I'm going to set the color of the pen, and then I'm going to call fill oval, and I'm going to call 0, 0, ball size, ball size. So that's going to draw a ball that fills the entire rectangle. If you look at the way the API looks for fill oval. Then you're going to create a picture object based on that and have transparent bright. So it's going to take the white background and turn it into a transparent. It's going to set the alpha channel. Okay, so you're going to make a ball with a transparent background with this method. Any questions? Yes, JJ. Yeah, so basic frame just has a static method on it that you can call whenever you want to create an image object in case you want to create, in case you need an image object for some reason. And you just specify the size and it does it. Right. And the second line is you can just ask any image object for its graphics object that you can use to draw on it. Any other questions? All right, good. All right, so that's how we, and this is a similar method that was on another class in this whole thing, create balls. So I'm going to create a bunch of different balls now. I'm going to create orange and blue and green and red. Okay. And then I'm going to create a sprite. I'm going to create a sprite class based on this ball, and it's going to have a super class for scene, just like always, and it's got a mouse clicked button. So if you click on the actual sprite, it will register with this method. And what that's going to do is it's going to set the picture to the orange ball. And then it's going to say if dead equal false. You know, it's just going to keep track of its dead state. And it's going to set its velocity to twice the velocity it was at before. So it's going to double both the X and Y components of velocity. Okay. Yes, Serene. Dead is just okay. So the question is, when I say dead, what does it mean? And dead just means I have a Boolean flag on my class that I set to true. That's all it means. I just named it dead. Okay. Let me make sure I'm saying the correct thing. Yes. See, it's just a Boolean flag at the top of the class. All right. We have process event for when it hits the wall. Okay, so let's take a look at that. So it's going to, when it hits the lower end of the wall, it's going to set its velocity to the absolute, to the low X value. It's going to set its velocity to the positive version of the X velocity, and the Y velocity is going to stay the same. So what that's going to do is it's going to make it bounce off the wall. So if it hits the left wall of the display, the X velocity will reverse and the Y velocity will stay the same. So it will bounce off the wall. Okay. And the same logic is applied to all the other walls. At the high wall, we're going to make the X velocity the negative and so on. And so it will just bounce off any of the walls. The balls will just bounce around in the inside. Okay. All right. Now here's the layout that we're going to use for the basic graphics example class. And it's a more complicated layout than the ones we've been using so far. You know, we had the most complicated one we've seen so far is 3 in a vertical row. And what this is going to do is it's going to have a 3x4 layout. Okay, and the way we're going to do something is if you want something to span more than one of these virtual cells, you repeat the name. So top L, top M, top R are all unique. And the next row, though, all 3 values all the way across are the same. So that's going to be one component on the layout. And on the next one down, row 3 goes all the way across. So it's one component on the layout. On the bottom, though, the left 2, row 4 and row 4 is repeated. So those 2 cells are going to be one component on the layout. And bot R is going to be off by itself. Okay, let's just run this application and see how it looks. I wish this would go up. Why won't this go up? I mean, it sometimes does, right? I don't know why what makes it decide to do it or not to do it. All right. So this is what it looks like when it's running. And you can see the balls are moving kind of slowly and they're bouncing off the walls. And what happens is there's this bat flying around in the interior. And whenever the bat collides with the ball, it turns it blue. And it just kind of bounces off the walls also. Now you're looking at the layout, right? Let's so this is not like a commercial, super slick product, but it's still kind of cool, I think. All right, so so you can see that this is row 2. This is row 2, and it's a label that goes all the way across. This is row 3, it goes all the way across. This button is row 4. It goes for 2 of these cells, and you see they're going to line up, right? It's going to size these virtual cells so that they line up. And then this is the bottom right corner, and these 3 buttons are the top left, top middle, and top right. Okay, so that's how the layout works, right? It's a virtual layout that you kind of draw with text. Does that make sense? All right. All right, let's go back and take a look at the rest of the logic. Yes. Yeah. So the question was, how do I decide how tall the middle component is? And the answer is that the framework figures it out itself. So each component has what's called a preferred size, which you can set. You can say on the component, you can say set preferred size and the new dimension, give it an X and Y size. And the framework will try to make it that size. You can also set a minimum size, and it will use those. And so it knows, for example, that row 2 doesn't need very much height. So it doesn't give it very much. So it just figures most of that out for you, right? That's the idea, is when you give it this logical layout, you don't have to worry about all these detailed numbers, right? And you don't want to worry about all the detailed numbers when you make a graphics application, because you might want to resize it, right? Not everybody's monitor is the same size. Some of them are small and they want to look at it on a small monitor, and some of them are huge and they want to make use of that huge monitor. So you want to be flexible if you can. All right. Finally, we get to the main method of this class. So as always, we instantiate a basic frame. For some reason, I called it fish. I create a sprite component. I create a button 1. And button 1 is going to have an add action listener, and what we have here, new action listener, is a anonymous inner class, right? If you have to understand that concept, you absolutely must. And then we're going to call JOption pane's show message dialog, which is just going to give you a pop-up message, and someone can click OK on. Then we're going to have button 1.add action listener foo. Oh, okay. So I assigned, what is foo? Hold on. A new foo. All right. So what I did is I created a class, right? This, for those of you who are still struggling somewhat with the concept of anonymous inner classes, I created a concrete class with a name, foo, that you can also use as an action listener. And that is sitting over here. And all it does is print the word click on the console. Now I can add as many action listeners as I want to a button. So the button can do a bunch of things if I want. And the thing is, right, and just in order to print this click using this foo class, I had to look at code in another class just to see this one line, right? That's kind of awkward. I think you'd agree. That's one of the reasons why anonymous inner classes are useful. All right. Set string layout. You have to set the string layout in order for there to be a string layout. I mean, in order for the layout to work, right? It has to be, you have to tell the framework about it. And then what you do as you add each component to the picture, you tell it where, which of those layout names it's going to use. So top L is going to go where you put the top L, right? And top R is going to go where you put the top R, and so on. Row 3 doesn't appear there, I guess we set it later, further down. All right. And so row 4, I said new picture, Sarah.ping. This was a drawing I made of Sarah from Chuck. Yes. Yes. Well, as I said, it's going to do it automatically. It's going to try to make, it's going to ask the button how big it wants to be. So I think if you have one button that's got a huge amount of text, it's probably going to get more space. It depends on how, what's going to work for all the other components. There is no provision in there for manually changing the ratio. You can use a more complicated layout to do something like that. Generally speaking, if you, my advice is if you want to do something really complicated like that, decide whether you really want to spend hours on it. Ty. Well, I think the basic layout on here is like a string layout with one component in it. It's just like one thing is on the screen. Oh, I'm sorry. There's another. I'm confusing something else. I'm sorry. No, okay. So there's another layout that I use with the coordinates, and I'm gonna do another version of this class with that layout, and you'll see how that looks. Yes.
So for the second row, since it's row 2, it's automatically going to show it the second row label.
Yeah, what it's going to do is it's going to just hand that label, the J label that says row 2. It's just going to hand it a region of the screen that fills that spot.
And so if you took like one of the row 2s and turned it into like say the middle one turned into row 2M, you would have to allocate something else for that.
Yes. Okay. So the question is, if I added another name to the layout string table, then I would have to add something else to go there. Otherwise, I think it draws something by default, which is like an X or something to let you know that you forgot. Ty. I'm sorry, what? Is there a way to make sprites overlap? Sprites will naturally run into each other and overlap, and you can set a Z value for them so you can see which one has the priority. And you can also set a listener to detect their collisions and do things based on when they collide. So you can have your plasma ball shooting out from something, and when it collides with an enemy, you can have it blow up. Yes, JJ.
Say that does happen. In order, say you want to like set something specific to happen for a specific group of classes or objects, could you add like a Boolean value if it collides with this specific object?
I'm going to show you how to do collisions in a bit. Okay. All right, so I'm going to create a new bat. Bat is my sprite. I'm going to create a dimension object. So this is going to set the preferred size for my sprite component. You don't need to do this. I've got a default set already. Got something in the air. All right. I create a random number generator. So that comes from java.util. I feel like I really want to sneeze, but it's not quite strong enough. All right, we have a key listener object, and this is a anonymous inner class, right? You can see the components, new, interface name, parentheses for constructor arguments, open curly brackets, and methods to implement. So if you want to implement a key listener, these are the 3 methods that you have to implement. Now, there's another class in the Java API called a key adapter, which implements key listener with methods that do nothing, so that you can just implement, override one of them if you want. Okay, so then we're going to do an add key listener to the basic frame component, basic frame. Now we're going to create a mouse listener. The same thing applies. So there's all these things you have to implement to do a mouse listener. And all I'm going to do is do this click one. But there's also a mouse adapter that will allow you to just implement one of those in case you only care about one of those. And so I'm going to set the mouse listener also. And now what I'm going to do is I'm going to go through here and I'm going to create ball sprites. Now we've already seen the code for the ball sprite, And I'm going to set the picture to either red or green, depending on whether I is even or odd. So I'm going to give you get an equal number of those. I'm going to set their velocities to random numbers. I want them to be in the range of 1 to -1. So I say 2 times random minus 1. And so since random is going to generate in 0 to 1, that's going to give me a value from -1 to 1. Make sense? All right. All right. So now we see how to do collisions, and collisions are kind of syntactically complex, but they give you something simple. So let's walk through it. So we're going to say we're going to add a sprite collision listener. That's the name of something that when you want two sprites to collide. And what you're going to do is you're going to have to pass 2 arguments. Okay, and the next 2 arguments are class names. And so this is ball.class. Now every Java class has a .class method on it, and the .class method is an object of type java.lang.class. And it's kind of like a blueprint object for that class. It's got, like, bless you, it's got all kinds of information about the class. And you don't really need to understand it in any detail for this course. The only thing that you need to know is that it's there and you need it to pass to this method. So what this class is going to do is it's going to implement a collision between a ball and another ball. And the next thing the third argument I have to give it is a new sprite collision listener. And that sprite collision listener is going to have the angle brackets on it, kind of like you do from, if you make an array list or something. And these 2 arguments, the types that go into the angle brackets on the listener have to match these first 2 arguments. So this is just a repetition, right? So you put the 2 classes you want to collide, and then you put the 2 classes again here. Now, if you want 2 different classes to collide, you can do that also. And you can make a sprite collision for each pair of classes or each class with itself, however you want to do it. And so that's how you keep track of which class collides with which class. And then inside the mesh method, you have a method called collision. And collision, again, has the 2 types, okay? It again has the 2 types. And so now, and these are going to be the 2 objects that collided. And you can just decide what you want to happen when they collide. Now, in our case, what we're going to do is we're going to get the velocity and the velocity of ball 1. We're going to set the velocity of ball 1 to the velocity of ball 2. And then we're going to set the velocity of ball 2 to ball 1. So they're just going to exchange velocities. And what that means is they're going to bounce off each other, right? That's what that's going to implement. So when 2 balls collide, they bounce off each other. Now I'm going to have a sprite collisioner with a ball and a bat. So ball.class, bat.class, and then over here we have ball and bat. And then down here we have ball and bat. And if you don't remember this, just come and look at the basic graphics example and you can see it again. Okay, and so here what I'm going to do is if the ball is dead, I'm just going to return. I'm going to do nothing more needs to be done. The ball is in the dead state. If it isn't in the dead state, I'm going to mark it as the dead state is true. Okay. And then what I'm going to do is I'm going to change the velocity to be half what the current velocity is. Probably dying would be a better name than dead. So whatever velocity it was going at, it's going half that speed now. I just multiply both sides, divide both sides by 2. And then I'm going to set the picture to the blue ball. So when it's in the dying state, it turns blue. All right. And then I'm going to put a clock worker, add task, and I have a die after. And whatever I set that constant to, it's 300, I guess. After 300 ticks of the clock, then what I'm going to do is if the iteration is equal to die after, if it's the last one, I'm going to call destroy on the sprite if it's dead. If it's still in the dying state, I'm going to call destroy on it. Any questions about any of that? Yes. Die after is just a constant. It's a final static int that I put earlier up in the class somewhere. And I just set it to 300. I just picked a number. Yes. Yes, 300 die after is just the number of ticks until the ball dies. Now, let's take a look at the code running again. Okay, so you notice as it collides with each ball, it turns blue. And then after a little while, these balls start to disappear. Now, if I click on them, they turn orange and then they don't die. So if I can do it, I can, sometimes it's, I'm not, geez, there. See, I can save these little guys if I'm fast enough and accurate enough. Why is that one not, I wasn't able to save that one for some reason. Yeah, I tried. Why is this? Sometimes it, yeah, maybe that's a bug. I don't know. I don't know why it would sometimes not work. I can look into, look, I don't write bug-free code either. So in any event, and now they're getting turned blue again. Eventually the bat's going to kill everything. All right. Okay. All right. Oh, and here's these buttons, right? I click on this one. Button 1 was pressed. And now if I go to the console, I don't know where it put the console. Well, on the console, it's going to print the word click. All right. Let me just go back and look at something else just one more time. I just want to make sure that you got it. So in the bottom left, you saw this woman's picture. This is my attempt at drawing Sarah from Chuck. And I just used her face as this button. And so the way you do it, right, is I load the picture from a ping file, which I have in my images directory. And then on the picture class, there is a make button method. And so if you want to have a button that has a picture on it instead of text, that's how you do it. Okay. Yes, Scott. Yes, I showed you that. There is a key listener. I did show it to you. Yes. And yes, see, there's the key listener. It was the very next thing. Okay. So, all right. There's the collision listeners. Okay. Then there's the clock worker initialize, which I used 20, which is kind of slow. And then I put move sprites. And then the last thing I did was I set row 3 to the sprite component and pressed show. Now, I didn't do anything with the scene. I could have put a background on this. I just didn't. Okay. And let's take a look at the bat. The bat is a fairly straightforward class. It initializes with the scene. It calls the super method as always. It does a set picture and it gets the bat ping as the picture. It sets an initial velocity. It has a process event where it bounces off the walls, and that's it. All right. Yes.
Is there a way to set like a hitbox for a sprite?
A what?
Like a hitbox.
Meaning what?
So like how your bat was moving, it would be like a square on the bat. There'd be a way to like minimize that.
Oh, okay. So currently your hitbox, your area for your collisions, is the size of the image that you use, and it's a square. And that's what you have. No, there really isn't a way to. The fine tuning is not what this class is. What this project is about. Yes, Michael, right? Yeah, you could make another sprite that's smaller, that's behind it on the z-axis, and only collide with that one. Yeah, you could do stuff like that. That would be a workaround. Any other questions? All right. Okay, so here is the same class re-implemented, and everything is the same except the layout. So I didn't use that string layout. What I did instead, right, was I used the coordinates, right? So this was Atai, I think this was your question. So in this one, I used the coordinates, and So again, I've got a 3x4 layout, right? And I've got for row 2, for example, that one went all the way across. And I'm looking, there's a, so like this one, right? That goes all the way across. So that's x equals 0, y equal 1, width equal 3, height equal 1. So that fills in that whole thing. Does that make sense? All right. So you can use either one of these, and they have different they have different rules for how they size things. Let me show you how that one looks. It doesn't look exactly the same. Okay, so what this one is going to do is it's going to try harder to make things, to make all the units the same, right? So these 3 widths across the top have to be the same with this one. And this one has to be 2/3 and this one has to be 1/3. And this one is, and this is also the unit of height, but this one has a 3 unit of height. Let's go back and look at that again. So yeah, so this one has a height of 3, right? I'm sorry, that one has a width of 1. There it is. Okay, so the sprite component has a height of 3. So it's got 3 of those. Whatever the height unit it comes up with, it's gonna put 3 of them there. Okay. So if you have to pay a little more attention to the sizing of your components this way, because you know your logical grid that the display is divided into is going to be equal sized rectangles. But it's going to figure out the size of the rectangle for you. All right. Yes, Ty. Right. Okay. So the question is, what about Ty got errors that said that you can't overlap it. So the thing is, if I put 2 things at x equals 0, right, I'm going to get that error. If I put something at x equals 0 with a width of 2 and a height of 2, and then I put something at x equal 1, y equal 1, that's going to overlap, right? So that's going to create an error. And anytime you overlap, you're going to get an error. It wants everything to lay out distinctly and not to overlap. So you have to think about it enough to not overlap. And it sounds like that's where you had a problem. Oh, well, you're not allowed to. The question was how you get it to overlap. No, the layouts don't let you overlap. You're not supposed to do that. Maybe that's not, maybe we can talk later. Maybe there's another way to do whatever it is you're really trying to do, but I don't think you want to overlap. Yes, Logan. Sprites can overlap. That's there's no problem with sprites overlapping, right? It's the layout, the higher level that can't overlap. Questions? All right. Where are we? So there's some other examples that are just in here. Those are the main. Oh, shooter. Oh, you need that one. Shooter. Look at this. Okay. We're going to have a shooter. It's called shooter. It's in the. No, this guy doesn't. This one does. It's a very simple shooter. It just sits there and shoots. Ah. Yes, I win. Yeah, okay. So it doesn't take incredible skill. But I did win. I don't always. Okay, so this shows you that you can actually have some performance out of this framework. It isn't dog slow, right? All right, so let's take a look at that. Base, where is it? Where is it? There it is. All right. So let's start with game. All right. Go to the top. Okay, so at the top, I have a bunch of constants. Now, generally speaking, if you're going to use a random number generator, the way to do it is to create a final static random rand object somewhere in your class and then just call it, right? Just have one random number generator to rule them all. And then I have some colors defined, a shooter color, a bullet color, an enemy color. So if I put constants that I define like this at the top of a class, that means later on, if I decide I want to change it, it's super easy, right? Because I've put everything in a consistent way into a constant. I put them all at the top where they're easy to find. And so if you want to customize the behavior and look of the class in some way, that's pretty straightforward. So that's just good practice. And so I have a bunch of constants here. I have big, small, enemies, board size, all these things. And once again, I'm going to have the make ball method, which, famed from Song and Story, with the same basic logic to it, right? It's basic frame, create image, get graphics, set color, fill oval, return picture, new picture. Okay. I'm going to create a sprite component. I'm going to set the preferred size of the board to board size. I have a string layout with one thing in it. I'm going to set the string layout. So the sprite component is just going to fill the whole screen. I'm not going to have any splash screens or menus or anything complicated. I create my shooter object, and it has initialized with the scene because it's a sprite. I'm going to create my enemies. I'm going to create however enemies I have. I'm going to do it in a loop. I don't need to assign them. I don't need to do anything with this variable assignment. I could just get rid of it if I wanted to. I just need to create the enemies. I'm going to create a key adapter, and the key adapter is going to do the key pressed method. It's going to do the key pressed method, and then it's going to that's interesting. Okay, it's going to do the key pressed method. It's going to do a new bullet, and the bullet is going to be instantiated with the scene and the shooter and the key code that was used. Okay, and then I'm going to set that key listener. Okay, so what it did is it I couldn't understand why it looked the way it looked. It had compressed the class for me, and that's the way I want it to look. So it's key adapter, new key adapter, open curly brackets, override key pressed, and then new bullet. Okay. All right, I'm going to add the key listener. I'm going to add a menu action. So there are menus up on the top bar of the application, and I'm just adding a couple of random things up there, which I didn't show you. So I'm going to add menu action. It's got to have help and about, and you're going to add multiple menu actions. And they're going to be, some of these are going to give you different things. Under the file menu, that we're going to have a load. Under the help menu, we're going to have a new game. So that just shows you how you can set that up. Let me just briefly rerun this, and I'm going to let it die, but I've got help and about and new game and file and load and store. So I could make those do things if I wanted to. Okay. But here I just show you how you can set them up. Then I'm going to add a sprite collision listener for enemy and bullet. Okay. And if the enemy and the bullet collide with each other, I'm going to play this clip, this enemy.clip noise. And then I'm going to call destroy on both the bullet and the enemy. And then I'm going to decrement the enemy count, which is a static variable that I have. And then I'm going to pop up a message that says and if that enemy count gets to 0, I pop up a message that says you win, game over, and call system exit. bf.show, you always have to show a basic frame at some point. You always have to initialize. And here I'm initializing with the interval, which is 10 milliseconds, and I'm calling the move sprites method. So that's, oh, and then I have a main method which calls game and calls g.run. So I put all this in, I guess, in a run method. All right, so that's it for the game class, but I have a couple other classes. I've got a bullet, and the bullet is going to create a picture based on the bullet color, and it's going to set its position and based on the sprite that it got. So it's going to get its position from the shooter's position. And then it's going to get a direction from either a key or from a mouse event. So there's another, so this is if I didn't show you using the keyboard. I can use the keyboard to shoot in 4 directions, or I can use the mouse to just shoot anywhere. I just showed you the mouse, but I have 2 constructors for this class, one that uses the XY of a mouse press and one that uses a key event, a key direction. So in this case, I'm computing the delta X and the delta Y from my shooter, and I'm using that to initialize my velocities. All right. Any questions on that? All right. Sounds like there aren't any questions on that. Let's take a look at enemy. So in the constructor, and so enemy has a static field on it called enemy count. I want to keep track of how many enemies there are. I'm going to call enemy count ++ in the constructor. This is just like we did in your A/B tester lab. We're counting the number of things. We're going to set the picture to another ball, right? It's just a big one. It's the enemy color. And we're going to set the X and Y position based on something random. And then we're going to just do some math here. Yeah, so what it's going to try to do is it's going to try to make sure it's not overlapping with anything. It's in a good place, and if it's not, it's going to try again. So it's doing this in a while loop. It's doing a random in a while loop. And then it's going to set its velocity to something random. It's going to have a reusable clip. It's going to have a process event. The process event, if I hit X low, it's going to do this little calculation to move me over to the right. So it's going to scroll. If it goes off one side, it'll come back on the other. We've seen that before with the dog. Okay. And that's it for the enemy. You got that? All right. Then there is the shooter. Very complicated class. It'll take me all day to explain. No. It just sets a picture and an X and Y position, and that's it. It just sits there. All right. Yes. What? Vanik? Vanik. Okay. Yeah, let's go back and look at enemy again. So enemy has got 2 constructors on it, right? I'm sorry, that's bullet. Okay, so enemy has got, maybe this is the thing that you were getting. So I was, what happened was when I started up the game, I had a tendency to die immediately. So I tried not to have it start too close, if possible. So that's what that loop is for. I'm just trying to avoid that. But essentially, it's a random position and a random velocity on the board. And that's the constructor for enemy. And then I have the process event. So if it hits the X high board coordinate, then it sets the X to 0, which is the low end of the board. And if it hits the low end of the board, it has to do a bit more of a calculation. So it has to get the size of the board and then get the width from that size. And then it gets the width from its own size. So it's going to move it over so it's still visible, but on the right-hand side of the display. Does that make sense? Okay, good. Other questions? Okay, so there's not a whole lot else to cover in basic graphics. So what I would really like to do is, since we have one more class period dedicated to it, I would like you to study this stuff and start thinking about what kinds of things you might like your final project to look like, and try to come up with some questions for next class. I will have more material, of course, but I want you to take a look at what we've got and think about it and be ready. Okay. All right. See you next time.